All right. Today we're gonna do another real-time estimating of one project, and today's project is called let's see, Riverhead Self Storage. Okay, let's open the documents. We have bid drawings, RFI responses, RFI responses. Oops, I always forget this guy. I'm new to this, that's why. Okay, let's keep going. Let me fix here first. This is better, I guess. You gotta fix your environment. You have to organize. All right. What should we start? It says speech RFI responses for older drawings and RFI responses new drawings. Responses for redrawings. Let's open the drawings. Let's see what kind of drawings we have. Structures. Okay, this is a storage building. Nice 3D image. And this is what? Let's look at the concrete is has to be 4,000. Let's say no. What we got here? Concrete notes. Footings 3,000. Foundation walls, basement walls, retaining walls 4,000. Piers 3,000. Slab on grade 4,000. Concrete slab on deck 3,500. Is it lightweight or normal weight? We'll figure it out. Lap splices 62 bar diameter. Okay. Here, normal weight concrete to be given at a hard roll finish. This is nothing to do with us at the moment. Now, time is an essence. We have to start this concrete slab on deck. It is right here. Normal weight. So, all the information I believe on this page. Total thickness is 5.5 inch, 2.5 inch concrete, and 3 inch deck. Okay, steel deck schedule. We don't need this. This is for roof deck, shear walls, SWA. These are panels, no concrete. Concrete steel lintel schedule. Concrete lintels, these are precast. We don't need that. Column and pier and footing schedule. That's all we need right here. Okay. Let's wall footing schedule. Another one. Why we got two footing schedule here? Column footing schedule, column schedule. Okay, it doesn't use the wall footing. How about the walls? It doesn't use the walls. Alright, maybe they show on the sections details. And this is the building. We got some details here. Column footings. All footings and all the details on the S200 look like 1, 2, 4. Okay, 3, 4, 3, 4, 3, and section 5 at this side somehow. And looks like this is the loading deck side, probably a wider footing here. And -4 is the top of footing elevation. Nice. I like to work with top of footing elevations always. Top of piers, 8 inch below. We're gonna take them all the way up. HD indicates Simpson hold downs each end of shear walls. These we gotta take care too. This is concrete guy buys this. I think each one probably $50, $60. We can check online. 8 inch CMU and CMU reinforcing is CMU shall be grout solid reinforcing one number 5 at each corner. Masonry jump bars one number 5. All remaining cells shall be reinforced with the number 5 2-foot on center. That's our reinforcing for CMU. We got elevated pit to them and 4-inch slab at the stair locations. Main slab 8-inch with ceramic steel fibers, and here 4-inch as well. We got some F2 footings here. That's amazing. It shows F20 footings here. They don't show footings here. Let's look at the. Where did I see TBD? I think. Hey, you got TDS, turn down slabs. So it is hunch. All right, let's look at the sections. It is hunch here too. So this is hunch. This is hunch. When it says TDS, turn down slab, that means it's hunched slab. So we got 3 sides hunch. Even here, I think. No, 2S200 between here and to the footing. All right, let's look at the 200. This has to be slab on deck. S1, S1, and S1. Everywhere S1 was this hatches. Does it say? Yeah, you go. It says indicates extent of change in the typical deck span. So we are not worried about it. S number indicates composite type of span direction. Okay. What's the slab? Slab they showed already, 5.5 inch. That's the slab CMU was. Okay, this is good. And this is roof. Beautiful. S200. Finally, we are there. Okay, they have a pour stop and a turn down slab, which is beautiful. But while we'll figure this, we're gonna figure this like this. Okay, no problem. 1, 2, section 2 as the curb to support the dirt. So grade is higher here, which doesn't make sense, but we'll do it. And this is the, I was gonna say lower and dark, but it's on the 2 foot. Okay, it is what it is. Now we can start work on it. What else here? Shear strap. Some typical details, I believe. And these storage buildings, they don't usually get reinforcing at the deck either. The reinforcing coming in. This is from the masonry contractor. And just 10 pages. Let's start. Let's create a new project. H56, and the name of the job is Riverhead Self-Storage. Riverhead Self-Storage. Bit date, we have to finish this today. And here we have foundation slab on metal deck and a side concrete. Just 3 trades. Foundation slab on metal deck and side. Yeah, 56. Let's open this, upload the structures. phone call again. Not easy. Anyway, we upload the structures, select all the pages, and let's start. I'm not gonna worry about all different PSIs. It's couple dollars difference in between. I just concentrate on finishing this very fast. Okay, these are there's column footings right there. Open split to the right. Where's foundation plan? Should be this one. And what's the scale here? 1/8. All right, let's keep it going. F30. Let's change this group name to column footings. Save. F30 square. This 3 feet and 1 foot. Top elevation is what? Should we do 3D? Yes. If you are not doing 3D, if you are not gonna check your entries by 3D, you don't even have to bother with elevations at all. But I like to do it. So top of footing elevation for F30. F30 is minus 3'4". Minus 3'4". This is top. Okay, so actually it was 3,000. Let's do the PSIs as well. Okay, it's gonna affect the lap splice on the rebar, but the column footings doesn't have a length, so it is not going to affect to any reinforcing at all. For the continuous footings, yes. Okay, everything is good here. Let's put this here, there. I'm just gonna go to the next one. Actually, let's add the rebar. We can finish the mark on the drawing later. For number 4, just for number 4 times 2 each way. Save and F40. F40 4 feet by 1 foot most likely, and minus 3'4" top elevation. 4x1. Got here, got there, and this one is 5 number 4s. 5 number 4 times 2. That's each way. Save, and the last footing is F50. 5 foot, and the minus 1 foot top elevation is minus 1 feet because these are interior. Add rebar, we got 7 number 4 times 2 each way. Save. Okay, now let's finish all the footings. Customer's calling again. Pause. Okay, back to the game. Where are we now? Any more column footings? No. Yes, we got F40s here, but the top of footing elevations are different here. Let's change the top of footing elevations to minus 4 feet. And over here, -4 feet. Okay, and that's about it. Now, let's open this page. What's the name of this? S100. And this was 001. Let's look at, and these are the detail pages 200, right? Okay. Okay, turn down slabs. Need to study this a little bit. Section 2 over here and over here only applies there. Section 1. Section 1, where is section 1? There you go. 3 foot minimum, so 2 foot 6. What we'll do is here, let's make this. This is 2 feet. If this is 2 feet, slope is 2 by 1, so this will be 1 foot. Because of slope, I'm going halfway, so that will be 6 inches here, and 2 foot 6. So my footing will be 3 feet, 3 foot wide, because this is 2 foot 6 here, and 6 inch extra there, 3 feet by 2 foot. Okay. But for the estimating purpose, when we're doing the job, we gotta put a post stop here. But the estimating purpose, I will take it up to here. And the slab is 8 inches. Okay. Now that will change. And this will be 2 foot 4 to the middle. And 2 foot 4, half is 1 foot 2. 12, 16 inches, and this will change to 8 inches. So that will be 3 foot 2 by 2 foot 4. Okay. I hope you understand this. Depth is 2 foot 4 because this slab thickness is 8 inches, 3 feet deep. So half of the 2 foot 4 is 1 foot 2. Why I got 1 foot 4? Hold on. This is because of 2 by slope, 2 by 1 slope. If this is 2 foot 4, this will be 1 foot 2. I'll put 1 foot 2 here, and I need half of the 1 foot 2 to get the average width. Half of 1 foot 2 is 1240, 7 inches. Not 8 inches, here 7 inches. And 2 foot 6 plus the 7 inches is 3 foot 1. Not a big deal actually. Okay, this is for the section 1. 3 foot 1. Come here. And the new group is turn down slabs. 1S200, right? 3 foot 1 inch wide, 2 foot 4 deep, and the top will be the bottom of the slab. So -8 inches. Slab thickness is 8 inches, and our concrete is what? Let's keep it 4,000 for now. I'll check. Okay, section 1 starts from here. Let's go a little bit in. A little more. 1 and shows 4. What is 4? Section 4 is 3 and 4. Same thing, 3 foot down. Does it have a curve? What do you think? Alright, let's go section 4 again. 4 and 1 is same. And coming back like this. 3, section 3 is what? Is it deeper? No, it's still 3 feet, but on the openings, this is usually where the overhead doors are. They make this because of the water, and where the door sits, so it seals it. That's the only difference. But I'm keep going up to turn down slab up to here. Let's see, 6 is 200, 5, 2, 1, 2, 4, 5. Huh. We were working on the section 6 actually, not 1. Oh my god, section 1 has a elevation difference. When you try to go fast, that's what happens. Let's look at the civil drawings for a second before making everything wrong. The drawings, civils, where is the civils? Architecture, electric, energy, fire, structures, permit set, main civil right here. Okay, C1, where is the grading plan? This is not sanitary plan, sanitary details, revised lighting, soil. No grading plan. And this one shows the grade drainage plan. Elevation is 23 here. 20 top of curve is 23.4, 23, 22.90, 22.90, 23.40, 23.40. And what's going on here? 23 something, 23.93. It's like foot above here. That's where you got the curb, and this building doesn't have loading dock. Okay. So most likely it's around 23. I'm not gonna worry about the height, and let's keep working on it. This is like some places up and some places down, so we better keep it the same. Okay, 6 is the same. 4, do we look at 3? 2, 3 is the same. Only 2 has the curve. 4 and go up to here. We should step this down, baby. There's a footing and a -4, and this is at -3. We need a 1 foot step. Okay. To be able to get a 1 foot step, we should do turn down slab, like 4 feet deep turn down slab at this piece right here. We didn't even name this. We named it group, named the wrong thing. Okay, I'll say 3 feet. Nah, turn down slab 3 feet. 1s200. Okay, and the group name will be, let's change the group name to turn down slabs. That's what they call them, turn down slab. I changed this, didn't I? Turn down slab 3 feet, 1s200. There you go. Okay, now let's add the reinforcement this guy. What I got? 3 number 5 continuous, 3 number 5. Yeah, that's a bottom bars, but we got, I better get everything here. I don't want to come back for the slab. So 3 plus 2, 5 number 5 continuous. Let's do top bars. Okay, do the right thing. 3 number 5. I want to do some shortcuts, but 3 number 5 continuous bottom. That's what we got here. 2 number 5 continuous top. That's that. And this says number for 12-inch on center. 3 feet. You have 4 bars for 3 feet. You got 2 of them that are the number 5, so you need 2 bars here. 2 number 5s, top, horizontal. Say, we got that. I gotta add this dowel. And that will be Z direction, and the range is the X. And that is number 4 bar. We'll select U bar. And here you get 24-inch on center. And this leg, it gives us 3'6". And downside is the depth of the R element. Footing is 3 feet. Turn down slab actually. That was, let's say. Save. We have dowels and CMU dowels. Where do we have CMU dowels? Over here. And on this piers. Okay. On those piers, each one gonna get 2 number 5s. And here we'll get number 5 2 foot on center. How long is this? 38 feet. So half of it, 15, 19. Call it 20. 20 bars here. And then each one gonna get 2 bars. Because jam bars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. You know what I'm doing? We use the software, right? Z direction. Number $5. Footing thickness is, I'll say 3 feet down, 2 foot 6 up. Let's call this 6 feet. CMU dowels. And let the software count. Whatever we get, we need to multiply by 2 because each location gets 2 bars. Nothing here. Yeah, we have it here. Not there. And this will be in the different. Actually, we're gonna get this also. Detail 6 is the same. Okay. So whatever we get count, we have to multiply it by 2. Plus, we're gonna add 20 more bars for this CMU over here. So 31 times 2 is 62, and the 20 more bars 82. Save, not done yet. We need to add this 6S200 here because detail 6 is this one actually. Okay. Alright, so this is 30 feet, another 15 more bars. For the CMU dowels, 50 more with the corners and extra reinforcing at the corners, couple more. So make it 100. Okay, let's look at the section 2 real quick. Section 2 is actually 2 foot shallower. So for the section 2, we will have I don't understand this detail. Because grade is up, we stepping up the footing. Okay, got it. Okay, now I have it. Okay, now we have 8-inch here. We have 2 foot here, right? This is 2 feet. This is, there was 2 foot, so no, sorry. This is 1 foot 4 here. 1 foot 4 is the, okay, 1 foot 4 is 12/16 and the half is 8. So this will be, this footing will be 2 foot 8 by 1 foot 4. Okay, turn down slab. This is 2 feet deep, and we said 2 foot 8 by 1 foot 4 inches deep, and the top is minus 8 inches. And concrete, we're still saying 4,000, and we didn't check it yet. All right, let's go red tones, and that will be, we had it in the wrong place. Activate this page and take it from here, here, here. As far as the reinforcing, they don't show the sidebar. They have the dowel. We got, we can add it manually. It's gonna be fast. So 2 for the 3, number 5's continuous bottom. And 2 number 5's continuous top. And the dowels 24-inch on center. Number 4's we select U bar, 3 foot 6 one direction, and the other direction is 2 feet. That's dowels. And now we're gonna add curb bars. So that will be Z, X. What does it say for that? Doesn't call for it. Number 4, 12-inch on center, let's say. Standard hook, and you got 1 foot, another foot, 2 feet. Curved dowels. That's done. Let's look at the 3D for real quick. Alright, so top is equal. We have a hunch. Turn on slab over here is shallower. But this will be like sloping like this. It's not gonna be like a straight cut like this. It's gonna slope here and slope there. What I'm gonna do is I'm gonna add a little piece here and a little piece there at lower elevation, so that will work nice. Let's try doing this first. Let's make it even, hold on. Okay. Just a little bit here. And added the bottom elevation, I will say -3 feet. Let's take a look what happened. See, I had a little piece to cover this hunch. Maybe a little more than needed, but that's okay. You always will need it. Copy paste here. And I need it over here as well. Copy. Can I rotate it? Not yet. Okay. We got these 2 pieces, and we got here. And here is gonna be something else. Anyway, let's come to this footing. Let's take 5S200. This footing is 3 foot below grade. It doesn't give you, yeah, it gives me top of footing elevation. So this is top of footing -4 feet. Let's do it. And I will say continuous footings. And more, what is it? 6, that's 2 foot, 3 feet, 3 feet wide, yes. 3 feet wide. 36 inches, 5S200. And we call them this continuous footings. Three feet and 1 foot deep. Top of footing is -4 feet. And these are 3000 psi. Color is okay. Okay, which is fine. I set the reinforcing. Nothing top because nothing above 12-inch concrete, everything bottom bars. So number for 12-inch on center and two number for additional at the bottom. So at the 12-inch on center you got 4 bars and the two more at the bottom, 6 bars. 6 number for continuous, and then short way. Actually this is 4 number 4 here and the 2 here. I got this some reason. I have to be careful today, my eyes doesn't work. And the y direction is that direction, x is the length, so 204 bars, number 4 short way 3 feet. I'll call this short way. Dowels I will add with the walls. Now let's take a look at, we need to refresh every time we had a group. Still didn't solve that problem. See, there's a big gap here. I gotta step this down or step this up. I have to do something. I cannot step this up. I gotta bring this hunch down. So what I'm gonna do is I'm just gonna, we don't have detail for this. We're just gonna add more turn down slab here. Let's add it like this. This is top is minus 4 feet, and copy, let's say another one here. Top is minus 3 feet. Let's see what we got here. We did it wrong. So top of this footing is minus 4. You know what? I'm gonna move this a little bit here and extend it like this and make a step. Top of this is minus 3 feet. This should be okay now. Minus 2 feet. There you go. Even I'm gonna bring this a little more, make it look like nice step. Yeah, a lot better. I got some extra concrete here, but it is going to slope from here down. You'll need a lot of concrete. And I should bring this line up, this with this footing, so I can make the walls shorter. It is there already. Okay, good. And we'll do something over here. You know what? I'm gonna do the same thing. I will use this detail. This top will be minus 3 feet. These are not shown in the drawings, so I'm just trying to cover the work so we don't fall short. At the other side, there you go. So we got, maybe we got more than needed, but that's okay. Little extra concrete, that's all we have. Now we're gonna add this wall. This wall is top of wall is, we have -4 here, and the 1 foot hunch, so wall is actually -1 here, 3 foot wall, but I will take it to the top. Why? Because a lot of framing here, a lot of framing. You have to frame this wall. It is 8-inch little wall, and then you have to frame this slab later on. It is a lot better if I can bring this wall to the top of slab and pour the slab against it, if they accept. But if they not, we do this, but I will take the wall up just in case. Okay, let's do the wall. Eight-inch walls. These walls are 8-inch. We have to be careful when you pricing these. It is same time it takes to frame this wall to frame any 12-inch wall. This takes less concrete, same framing. So when you pricing this wall, you have to be careful. What is the practical way of pricing? You need to calculate how much it takes if it's 12-inch wall. Then you find the difference on the cubic yardage. Let's say 8-inch wall takes 80 yards, and the 12-inch wall, if it was 12-inch, it was going to be 100 yards. So 20-yard difference. You price the 8-inch wall as it's 12-inch, and give them a credit for 20 cubic yards of concrete, just the material. That's how we price it. One day I'll show that. Continuous footings. Now we're gonna have new group walls, and it's 8-inch. We'll take this 4 feet, and bottom is -4 feet. And this will be from here back. I will take it up here. I'm not gonna worry about these steps. Okay, let's take a look. See, this is the wall we got now. Alright. At the reinforcing, we don't have any CMU here. So what does it say? Number 4, 12-inch on center each way. That was to match verticals. And we gotta add this dowel. XZ. This is the, anytime you're doing horizontal bars, one on top, one on top of on the other one, each other, top of each other. That 5 number 4, it gives you the quantity 4-foot wall, so it's 5. Actually, one of them is number 5 at the top, so we do 4 number 4 horizontal, 7 new XC1 number 5 horizontal, 7 new scaling, 4 number 4. We got one corner. Corner bars. Yeah. One number 5. Corner bars. No, it's not one. Sorry. Just losing my 5. Yeah, it is one. This one for the one at the top. So there was only this corner. That's about it. And no, I didn't add the verticals at all. Verticals, it shows two bars. They have 1, 2, 3 bars. I will make one bar doing like U like this. So we save a little rebar, maybe we get the bid. That's how you make the difference. And this is, but these are 12-inch on center, this is 24-inch on center. So what we'll do is every 24-inch on center U bar and another 24-inch on center L bar. 24-inch on center. Number 4, we get a U bar. We got a standard hook, 4 feet height and 3'6" horizontally. This will be dowel plus vertical plus slab dowel. 7 new, again 2 foot on center. Let's fix this. This time on the verticals, because this is every 2 foot on center and these are every foot on center. And select this. And this will be for 5 feet. We messed up on the height on the other one. Dowel and vertical. Save. I was wrong on the this bar. Okay, I was wrong on this because we coming like this, going all the way down. So 4 foot, 5 foot. This will be 5 feet. Okay. So far, so good. We got those and the piers, P20s. Piers, we gotta get 4 feet piers. We got another pier here. What's the pier? There's the other guy. P20, 2020, 12, number 6. Oh, a lot of number 6s. Okay, here we say piers. P20. 4 feet. Square, and this will be piers 20-inch, 4 feet high. Bottom is minus 4 feet. We're still gonna check this PSI, right? Walls was 4,000 PSI actually. We gotta look at those. Let's look at it before we go further. Okay, footings and walls 3,000 PSI. No, it's not. It's footings, spread footings and wall footings 3,000. So footings are 3,000. Walls, piers, we're gonna get 4,000. Let's see. And how about slab? Full slab is 4,000 as well. So turn down slabs, we had 4,000, which is good. Footings, we had 3,000. Quantities footings, we had 3,000. That's okay. Walls, we need to have 4,000. And the piers, we got 4,000 already. Alright, we fixed the PSIs. P1 with P20. Add rebar with that, with set 12 number 6 ZX12. Number 6 double and vertical. So this will be 5 feet. And this is double and vertical. And now we're gonna do ties. Arrangement is like that. No matter actually. Number 4. Anytime it's number 3, I use number 4 because it's number 3 is not available in this area. So here you cannot buy it. If you try to buy it, it becomes more expensive than number 4. So that's why I use number 4 right now. So ties, yeah. Now we do the other piers. Another one here. P20, normal point. P20. You got P20 here. These are okay. 3'4". I got 4 piers. 4 foot piers. If you get 4 foot pier for the 3'4" pier, it's not a big difference, but you gotta do the correct. Top is 0, let's say 4,000 psi, and add it here. And the reinforcing, we gotta copy from here. Only thing we're gonna change is double arm vertical is not 5 feet here. It is 3'4", 4'4", 4'4". 4'4". It's funny, right? So we took care of that already. We have more here. Let's change color of this. A lot of red. Orange, blue. Why not blue? Here, here, here. No more. Okay, what did we miss? We have step footing 1, 3 to step down. Okay, 20. This is wall footing, 2 foot by 1 wall footing. Continuous footing 24 inches. Continuous footing is 2 foot by 1 foot. This is 3,000 psi in the brownish color. And the top elevation right now we have -1'4". That's what it's showing here. And that's what we're gonna do. Okay, 3 number 4 continuous and number 4 24 inch on center short way. Okay, now we gotta do the, actually before we do the step footings, let's do this one also, because it's going to be similar. We're gonna connect this to the bottom. So we're gonna go to bottom of this footing, and that was -3 feet. 6 is 200. Is -3 feet is the bottom, so -2 foot. We are at the -1'4", -1'4" to -2 feet for the top of this footing. We got 8 inches. So let's do trial. No, not this one. We don't need that. Alright, continuous footing CF24. What we're gonna do is we're gonna come from here underneath the higher footing. Let's see what we're doing here. Top should be, I'm going 8 inch down from this, so minus 2 feet. Let's see where this guy is. Okay, I'm here. And bottom is matching, and that's about it. That's the solution. That's how you step it. But what you're gonna do on top of between slab and this, I mean, we should extend this all the way down because we need to put either a wall here, they don't show any wall, or we need to fill that gap with concrete. You know, CME wall will sit on this, but what will happen here? Is it gonna step down? No, we're gonna use a straight concrete. We fill here, so CME can sit on a solid space. Alright, let's copy this first. Put it here. Okay. Right there. Right here. Didn't fit here, right? So it's supposed to look like this. Alright. You have to think about the worst case scenario. Maybe we got a lot of hunches here, but that's okay. Okay, so we're done with all the walls, footings, and piers. Now elevator pit. Where's the elevator pit? Right here. 12-inch slab, number 4 or number 5, 12-inch on center each way, top and bottom. Okay. 12-inch head slab, reinforced. Again, red. Mat slabs. And the top of the concrete is minus 4 feet. Top elevation, and this is footing 3000 psi. Can you consider that as a slab? Yeah, why not? Let's consider that as a slab. 4000 psi. Add rebar. Very simple. Number 5 times 2. No, times 4. I'm sorry. Each way, top and bottom. Capital right. Each way, top and bottom. Let's copy this if it fits here. Almost perfect. And then we'll do elevator walls. 12-inch, nice. 12-inch elevator walls. 4 feet, we'll say they are less than 4 feet, but I'll go with 4 feet. I go into the walls. 4 feet. It's gonna be 4000 psi. And the bottom elevation is the minus 4 feet. Greenish color. And get it all around. Okay, each face, it says number 4. Where does it say? I just saw it. Number 4, 12-inch consider each face. So let's start with the horizontals. Number 4 times 2 each face, because horizontal each face. Again, we're doing the same thing for the horizontal bars, but this time we're doing corner bars. Lap supplies each leg times 2 for each face and times 4 for each corner. It has 4 corners times 2, 8 corner bars. Verticals, we're gonna do double on vertical. Number 4, and this will be 5 feet. Each face times 2. Double and vertical. And the CMU dowels, we already know. Number 5, 24 inch on center. And this calls, I will call 6 feet. Okay, where this guy? Elevator walls, and I'm gonna continue the same wall over here. Pretty much I'm done. Now, what else I'm missing? I'm missing some anchor bolts. Let's say base plates and anchor bolts, whatever. Square, and this is gonna be in the miscellaneous items. And this element is not concrete. Bottom is the 0, 1 foot diameter. These are 20 inch. We call them 1 foot. Okay, 1 inch thick. Let's say bottom of the plate at the 0, which is fine. I need count on this. Select the formula as count and place this base plates. We gotta set the anchor bolts on these column footings and piers. Like 15 count. Okay, we need the rigid insulation around. Let's see, architecture's plans. Structures doesn't show the rigid insulation, I believe. Do they? No, they don't. So we got 3 foot vertical, probably 3 foot vertical rigid insulation all around. Let's see. Architecture plans. What does it show? I see. Yeah, we're gonna take it all the way down 3 feet. And a 4 foot here, right? And let's say 2-inch rigid insulation. So we got 3 feet deep. Thickness is 2, depth is 3. Top elevation, we get it from 0. This is not a concrete. And I need X length times Z dimension. X times, so side. X times Z. Right here. And this applies to, come on. You put it on the wrong spot again. This applies to here. Exterior of this. I'm gonna get this is 2 foot deep, but I will continue through. Okay. Remove this for me. And 2-inch rigid installation, 4 feet deep. So this will be 2, that will be 4 feet. Top will be 0. This is not a concrete. We need X times Z. So side. A little bit turning from here back. That's it. We got the rigid installation as well. Now go to slab. Slab doesn't have reinforcing. It shows ceramic steel fibers. Okay, at the construction joint we got some rebar, metal keyway. You know what? Let's put the slab first. 8-inch slab on grade. With 50 pounds per cubic yard ceramics steel fibers. 8-inch tops elevation is 0 and the 4,000 psi. Yellow, and this is slabs. We got them edge to edge. Now these are 4-inch slab on grid. We forgot about this 4-inch guys. I'm gonna get this on. Yeah. Get to the edge. We will deduct for elevator pits. Okay. Subtract. No, subtract. Let's say again. Okay, now 4-inch slabs. We need to check vapor barrier. I call for it. In the storages, steps usually steel steps, not pan fill. So we are not gonna worry about it. Let's see the section detail. Let's see. Around the steps, you got curb. So we have to add a curb around the stairs. Not at the interior side though. Exterior side, he has a curb, but doesn't show me the something here. Waterproofing. So everything is waterproofed. No vapor barrier. So we can exclude. Come on. What happened here? Okay, we have to finish this first, I think. 4-inch thick. With what? 6644? 6688. 6688 WWF. Okay. Exclusions. Oh, vapor barrier. Let's list first. Vapor barrier. And waterproofing. Okay. I got everything here. Now second floor. First floor, I'm not missing anything else. Now we go into the second floor, which will be slab on decks. This was foundation, this second floor. Ah, don't say you got everything. We forgot the curb. Okay. What is 6-inch concrete curb? 6-inch curb. A little bit curbs. Height is 12-inch. Bottom is 00, 4000 psi. And I would get it through like this. It will be around the stairs also, we said. 2S200. And over here. Head rebar, one number 4. We already got the dowels, we just did that. One number 4 quantities. Now we're down. Go to slab on decks. You can close these guys. Here, scale is 1/8. Actually, slab on deck was given where it was here, right? Concrete slab on deck. 2.5-inch area. 2.5-inch normal width NW. Slab on 3-inch metal deck. With 6688 WWF. W2.0 by W2.0 is new. They call it newly like this. Before it was 6688. Now they call it W2.0, W2.0. That's why I call 6688. So 5.5 inch, and the top elevation is 4,000 psi. I think 4,500 they call it for the slab. All right, and that's about it. And here we are not gonna deduct any openings for the elevator and stairs. Nobody does, because you have to protect these openings. You have to put some guardrails around them, and you have to protect them. It has some work. I mean, concrete to cover this area, even not gonna be enough to do the labor for those guardrails. Anyways, S101. And slab on decks is done. On the roof, there is no concrete, I believe. Let's look, make sure. D1, D1. It says D1 here. Everything D1. D indicates metal roof deck. So D1, D1. No concrete here. Okay, that was first one for the slab on decks. Now side concrete. No, this is not side drawings. We gotta get the side drawings. Civil. Select all, load. We're already in 1 hour and 20 minutes in the takeoff. Okay. Let's see, what is this for? This plan called NYSDOT site and landscaping plan. So I think this is shown off-site work. Okay, gonna need this. Scale is 130. We better scale this 30 feet, 60 feet. I'll go 60 feet. 60 feet from here to back. Okay. And this is the blowout for this actually, right? This look like that. Yes. And this is NYSDOT partial site and grading plan. And this is 110. Let's see if scale works. 1 inch per 10 foot. Yeah, that's good. Everything is here. Okay. What's next? Yeah, this is some kind of drainage plan. I don't need this one. And what's this one? This is a utility plan. Not this one. So here's my plan. Light posts. I'm gonna need this one too. Let's say 130. How about this site plan? Erosion. So I guess site plan is this. Let's see what we got here. I think this is enough for me. Okay, let's see the section details. This doesn't have any. Let's see if this does. Yes, this one has details. How about this one? This is nothing to do with us. Okay. Concrete services. Pavement thick plus 6-inch. 6-inch concrete curb VF6. Sidewalk is a 4-inch sidewalks. Curb is 8-inch by 18-inch. Detectable warnings. All typical concrete pad. We don't have any idea. Okay, let me look at this. Anything I need to graph from here. It starts from end of the property line to the end of the property line, maybe a little past. And you got handicap curbs, handicap ramps, and curbs. You got a curb here, you got some pavers. We are not doing pavers. And a concrete pad here. What are these proposed road tops? So RPZ pad or anything? Let me see. That utility plan. Which one was it? This one. Doesn't temporary source stock, but it doesn't call for these guys. We got this already open. Okay, let's go. I know what to do now. Curves. 8-inch by 18 inches, and the top of the curve is +6, 0, let's say. And 4,500 for site concrete. Okay, I see. We gotta come in for the handicap ramp. Come out. And that's how it is. A lot of curve, huh? I don't see dumpster pad. We have an island here. And this side we're gonna come. Loading zone. Okay, 4-inch sidewalks. At the road. Is it 9 foot wide? let's see. Sidewalk is 5 feet. Curbs I gotta extend here. Let's keep going on sidewalks. Orange handicap ramps. Handicap ramps. Okay, here. Detectable warning fields. 2 foot wide, 1 inch thick, and I need the square footage. X times Y. Those are the detectable warning fields. Okay. Detectable warning fields are the for the blind people with the stick they can detect little dots on that space. It's like a usually yellow, could be different colors too, and it has like a recesses like this. There's like a little dots on it, and they can hit with the sticks and detect what's going on. All right, what else we got here? Propose underground electric. Okay, concrete pad here, 6 inch thick concrete pad. 6 inch concrete pads. Okay, we got the sidewalk, proposed payment, proposed sidewalk, proposed road topsoil, 15-year setback. Nothing to do with us over here. Sliding door, canopy over. You know what I'm going to do? I will add a little bit pad over here. That's what it usually does. They put little pads in front of the doors. This is landscaping, and we got the curb over here. Yeah, we do. Just doesn't seem okay here. Topsoil, ramp side. I think we got everything. They talking about some bollards. Maybe at the building corners. Well, best place to look for bollards is architecture's gonna be. Let's see. Now there's a show. There you go. 2 bollards here. And at the doors. Okay, let me get this plan. A101. bollards are site concrete item, but they shown in architecture sometimes. Yeah. Is it A101? I think so. Come on. All right. Another phone call. Okay, let's continue where we left off. We need to find the bollard detail. It could be anywhere. There you go. What we got here? See, we find a couple more concrete. Some more bollards and gate control keypad. And these guys need footings as well. Concrete pad, 12-inch concrete pads. Concrete yoke pad. Section 2. Alright, let's get this page 2. They have a site plan here. And they don't have a dumpster pad. Let's get this drawings as well. Propose RPZ hotbox location. What page was it? Come on. A001. Upload architectures. And this is the one. Okay. 1 hour 38 minutes. We gotta finish this takeoff. I need to send this price today. On this page, there are different scales. I want to work with this one. 20. And this page, let's name this page A001. And we work on this page as well. A101. A101. And scale for this is 1/8. Also split this to the right. Let's get the come on. Bollards are 16-inch round, 3'9". I will make a 4 foot because of we need to fill the bollards as well. 16 by 4 feet. We call bollards. Group 1 is the site concrete. 16-inch by 4 feet, and top is 0 concrete. 4,500. Let's get a red. We need to make a round. Okay. We have 2 more here. A lot more here. And that's about it. Around the building we have some bollards. Now let's go to this page. We got the bollards for these guys, and I need bollards for this one. We have 1B and 1A. And where is 1B and 1A? First one is this. Bollards at key box. It says, let's add bollard here and bollard there. And for this one, 4 bollards. It says 1, 2, 3, 4, and 3 here. Concrete pad. So 12-inch concrete pads. I need to get here and here. And that yoke thing. Concrete yoke pad. And I'm gonna add, instead of the yoke pad, I will add another bollard. Okay, these are not big. Let's say 12-inch concrete pads. I'll go here and another one here. And the approximate location of transformer utility company. I'm gonna add 12-inch concrete pad for transformer pad as well. And I will add reinforcers still for this. Each way, top and bottom. Number 5s. I already got this pad. RPZ usually get pad as well. These are small items. I have to include them. If they don't want it, I have to specify I have a pad for RPZ in my proposal. So they say, if they say no, take that out, maybe plumber gonna do it, then I will take it out. Okay, one last thing left is light bulb bases. C1. Where is the light bulb bases? Drawing A. Oh, this is the drawing for the light bulb bases. It's a very deep light bulb base look like. Do we have a schedule? Minimum foundation embedment is D, and it's coming up 8 inches. It should say somewhere what's the depth of this pad light bulb. It's right here. D is 4 feet. Oh, it's not deep at all. So minimum foundation diameter is 2 feet by 4'8". Let's make it 5 feet. This is maximum, yeah. Light pole. Can't spell anymore. Light pole. Bases. 2 feet by 5 feet. How many we got? We can do from here. These are doesn't require poles. These are the ones with the poles. It says this one is attached to the canopy and these attached to building. The one with the poles we need. So we need 4 light pole bases. Just take a look at it. And it called for D, E, and F. D is here 1. These are 2, 3, 4. Okay, pretty much we're done. Let's change this to side concrete. And let's go to our takeoff page. I want to rearrange these groups. I will start with column footings, continuous footings, turn down slabs. Basically, they are footings as well. And then mat slabs, then slabs. Hunches we got with the turn down slabs, so we don't have hunches. That's why walls, piers, curbs, and miscellaneous. And then at the slab on deck, we just have slabs. We don't have nothing else here. Okay, and then side concrete is the side. Here, let's fix missing volumes, formulas. We got all these formulas. We need count for the base plates, rigid insulations, we need square footages, that's correct. Curve, this still curve coming down. We just fix this. So there's a bug we already see. Slab on deck is okay. Detectable, and here bollards with the volume. Everything is done. And this is our takeoff. When you click PDF, you get the PDF out of it. You can use our pricing tab, or you can price it in the Excel, wherever you want. This is the takeoff sheet. Thank you for watching. In 1 hour 49 minutes, I was able to finish this takeoff. This was a lot simpler, and I spent little time to explaining for you guys. Hopefully you like it. All right, I'll see you on the next one. Thanks, bye.